Hi, my name is Maria Phillips, and my project is identifying human trafficking in online communities. My focus is looking at the literature review of what's been done here and creating a recommendation for text analysis for future research. So the problem is that as technology has advanced, a lot has transitioned online. We even can shop for groceries online. So human trafficking has also become more prevalent in online communities and is conducted with greater frequency, especially over the last 2 decades. And so as it's transitioned, there's many techniques within using artificial intelligence methods that could be used to help identify this explicit behavior or this type of behavior going on, which isn't necessarily being utilized, or at least not on across all of operations. There are still those conducting human trafficking, anti-human trafficking operations that have a single person just going through looking through post by post trying to flag when there's certainly methods that could help flag this for them. So some of the gaps that exist, there's not a lot of historical data that's easily accessible or available. There's a lot of shifting behavior as those conducting this try to avoid detection. There's not much research that's published. There's even those that have been published, they don't tend to incorporate models that have interpretability. They focus a lot more on like the accuracy of the classification, which means that the model itself would need to be implemented rather than the information that from that implementation or that analysis be shared across a wider range of those conducting anti-trafficking operations. There also appears to be a lack of vision for those that have developed these models for how to actually transition their information into into application. And lastly, there's just not a centralized data source for this, for where this is conducted, especially as 2 years ago, the web page that was used for this was shut down. And then even within each of the communities, there's certain nuances within the language emojis or other types of hashtags or certain acronyms, etc., that are specific to this domain and specific to those online communities, which are very difficult to detect and difficult to kind of process through as these models are developed or suggested. So for this next section, I'll just talk about what exists within literature and within the web that could be supporting this type of operation. So Deliver Fund is just an example of one of the organizations that exist where they support the government operations by providing the evidence, and so they're actually using image processing, computer vision, basically, so they're able to identify objects within a room, and then maybe if a certain set of objects exists within the same image, that might be reason to flag, etc. So they're able to train their models based on using that information. There's existing data, mostly in the form of statistics. There is one advertisement data set that I identified called DARPA Mimics, that was scraped from the dark web, specific to human trafficking. However, you can't get access unless you're working on that project. And then you could also scrape data yourself. So Deep Dive is a scraper that was actually used to scrape DARPA Mimics. Twitter has an API. Craigslist, there's available code on GitHub. And then there's whatever your knowledge is to collect on other sites as well, such as Facebook Marketplace or Instagram. So what's been done? So there's been research published that is related to data mining, basically trying to identify these patterns. It's just unclear that how much of that research has transitioned to application, as I mentioned. There's been several within recent years that discuss natural language processing techniques such as sentiment analysis, trying to identify the meaning of emojis within this context, that type of thing. And there's also been those that have focused solely on the imaging aspect, trying to identify images that might be flagged for suspect behavior within this community, and even some that have combined both of those, trying to use maybe the hashtags and the text as well as the image in order to create a better model of accuracy. And so far that appears to be the most cutting edge side of this research. And so my focus is mostly on the natural language processing. And so, as I mentioned, a few of the papers did discuss methods that they used. And so these are just some of the different techniques within natural language processing here on the right that you can see. And so the ones that I was able to find in literature include sentiment analysis, topic modeling, text categorization, and text clustering. There's also many models that were focused on trying to come up with the best accuracy. And so they ended up using basically neural networks or LSTMs as a common way to try to basically identify or classify as part of that text categorization. So if, as I mentioned, one of the big gaps is actually interpretability. It seems like most of the models focused on developing the best accuracy without a consideration for how to implement that into application. One way to take a different approach would be to try to focus on the interpretability, and then whatever results could not only be incorporated into a model that could be used to maybe improve in the future the accuracy, but it could also, whatever the results are, could be used as a way to inform future researchers or those conducting anti-trafficking operations that don't have access to a sustained implementable tool to help them with their operations. So if there's a general rule of certain hashtags or other things to look for, this type of information could be widespread across those conducting these operations that could at least help them in what they're doing. And so this first recommendation is basically just an example of how you could conduct text analysis in this domain to see advancements in interpretability. And so for this example, the data that would be needed could come from Twitter. And so for Twitter, there's a lot of different types of information that could be included. And so there might be a username in a tweet, and you could collect this data using a hashtag. And so I'll just show you on the next slide. This is the data collection process. And so you have your list of hashtags that might be identified previously through a domain expert or other published research. You ask the API to collect that data over the past 7 days, and anyone that has posted that, you now collect that username and the entire tweet that they posted, and then you just scrape that data, and you continue to scrape it over a period of time. And as you scrape it, you might identify other relevant hashtags that exist within that data set as well, and you can add that to your list, etc. And so now what you end up with is a list of users and their associated tweets. And the first step would be in pre-processing would be combining all of the tweets that a single user posted for that one user. And so now you have their entire pooled tweets list, which could be considered a document. And then you can extract the hashtags from that list. And so these are kind of the relevant pieces of information. So you have your Twitter users, which we'll refer to as M, and then you have the hashtags that they've posted, which would be N, or it could be an item in a recommender system. So a base model is very important just as a general reference, so that way you know that with whatever your recommendation is actually improved upon it. And so a very simple base model could be represented as this. I just don't have time to go into the details. And this would be a step up of how to incorporate interpretability. So one suggestion could be using a recommender system called latent delay allocation, which on the surface doesn't appear like it would have much interpretability because of all of the latent features. So I'll just go over quickly this graphical model. And so in this example, we mentioned there's users and their associated tweets. And when you pull those together, they make a set of all of the tweets that users posted. And so that'll be referenced as a document. The topics we can say are actually the hashtags potentially. So basically everything that you see here in this graphical model, you have the proportion parameters, you have the per document topic proportions, you have the per word topic assignment, you have the observed word, the topics, and the topic parameter. The only thing that you see is the observed word. So those are the words within the document. So the words that the user tweeted. And so with that information alone, and these other parameters, you're able to identify, if you set the parameters of K, for example, which is the number of topics that you're interested in, now you can identify all of these other parts of what this structure would be in this system. And so the pseudocode is here on the right. I don't have time to go through it. But essentially what you end up with is topics that are associated with this corpus, and a corpus would be all of the different users that have tweeted all of their combined documents, which would be their associated tweets. And so through that, you come up with topics, and through those topics, you could potentially identify the most frequently used hashtags or other keywords that could be used to represent that topic. And so even though it's a latent feature and it's not clear exactly what the meaning of that topic is, that topic itself could have some sort of a hashtag associated with, or some other sort of information that could be relevant and useful for interpretation. And so that's the recommendation. The way that you'd evaluate this model, there's basically a few different ways. The main thing is, if you train this model on a certain data set, and then you've held out some information, and then run that same model on this held out information, how does it perform? And so rather than just a binary yes, no, this is suspect, perhaps it would be yes, no, has this user used this topic or this hashtag before? And so here, these four equations are common ways to evaluate like these type of categorization models or recommender models. It also might be, out of the top M recommendations for hashtags, how many of those did the user actually use? There's a few other ways that you could predict, but ultimately what you're looking for is it useful for your purposes? And since the purpose of this recommendation is to actually fill the gap of interpretability, it's mostly, is the interpretability, does it have any sort of a meaning that seems to be translated into actuality? And that could be, and that's why I think actually the F1 or the RMSE might be good metrics in this case. So in conclusion, I was able to just do a quick survey of what the recent research and data related to these text analysis methods have been applied within this domain, and then provided a baseline model and an attempt to improve that model using a recommender system with the focus of trying to increase interpretability. The limitations, there's many limitations, as there's this focus was mostly on text analysis. Even in the recommendation, it doesn't even have a image consideration. There's many other methods besides LDA to consider. There's many other extensions to LDA, such as a time component that could be incorporated, which was not. And then there's also a lot of, I think, actually the most useful thing would be a hybrid approach, which would incorporate some of these things like neural networks or using BERT to try to do this classification with this interpretability of incorporating a topic model or a recommender to try to increase the value of the information to those who might not have access to a sustained model or implementation of the model. And that concludes my presentation. Thank you.